All right, here we go. Acceleration in 2 dimensions and higher. Well, I'm going to spend even less time talking about this. The acceleration vector, average, would just be the change in the velocity vector over the elapsed time, and instantaneously, it would be the derivative of the velocity vector with respect to time, which means it would look like the second derivative of x with respect to time in the I hat direction, plus the second derivative of y with respect to time in the j hat direction. And if we're in higher order dimensions, like 3 full dimensions, we'd have a plus the second derivative of z with respect to time in the k hat direction. I should talk about, for completeness, there is still a magnitude of the acceleration vector, and it is, again, the square root of the dot product of the acceleration vector with itself, or take the second derivative with respect to time of x, square it, take the second derivative of y with respect to time, square it, add them together, and take the square root. All right, other thing you should know. This top definition, the acceleration vector, that's the one that must be constant. To use kinematics, I don't have enough space on that line. To use kinematics with constant acceleration. The magnitude of the acceleration, I mean, sure, we could have that be, we could have that be constant, but if it's changing direction, it's not actually constant. So true constant acceleration requires both the magnitude and the direction be constant. So it's only if the x component is not changing with time and the y component is not changing with time, only then can we actually use the constant acceleration condition for kinematics. I bring that up because we're going to talk about kinematics constant acceleration in 2 dimensions next, and then we'll talk about kinematics when we don't have constant acceleration right after that. Then we'll get into projectiles and problem-solving methodology and other topics of the chapter. All right, that's about it for acceleration in 2D and higher. It's a nice short little section. If you have any questions, contact me with them, or we'll be talking about this hopefully during class.